Assalamualaikum. Hi friends, I am Inshila Shafat and I again welcome you back to my channel Radiology Fundamentals. Hope you're all good and doing well. Let's start our today's topic, which is X-ray cassettes. As already in our previous lecture, we have discussed about X-ray films. So it must come into your mind that there should be something that can hold an X-ray film. So of course there is that something and we call it as radiographic cassettes. Let's discuss them briefly. In radiology, there is a square or rectangular holder made up of plastic or metal that holds X-ray film, which we call as radiographic cassettes. So here's the diagram of a radiographic cassette, X-ray cassette, which is used in radiography. It has got many parts. Check it out. Here we go. The different parts are front part, which has got front intensifying screens. Back part has got back intensifying screen with lead foil. In the middle is a hinge, and in the back side there's a foam pressure pad. Above it is a sliding shutter for use with patient identification cameras. Here from front side there's a lead blocker. Alright. So first let me show you the simple and the basic definition of radiographic cassettes, which I mentioned here, that cassettes are rigid holders that contain the intensifying screens and film. It means these are the cassettes which hold the film, plus they are the one which hold the intensifying screens. As I have already mentioned about the intensifying screens, a simple definition of intensifying screens, it is that which converts the X-ray photons into visible light. So they are also holded up in cassettes. Now moving towards the construction of cassette, which is very much important as far as the examination point of view is concerned. As already discussed, cassette has got two main parts. One is front part and the other is back part. Moving towards the first one, that is cassette front. Its first point says that the front should be uniform thickness and density. Means the front portion should have a same thickness all around and should have a mass. Second point says that if metal is used, thickness should have an all equivalent of number more than 1.6 mm when used at 60 kVp. Which says if the front portion of cassette is made up of metal, that metal should have a thickness of mass of number more than 1.6 mm when used at 60 kVp. kVp is the kilovolt peak, means the maximum voltage used by X-ray tube to produce X-rays. Now moving to the third point, which says if plastic number more than 0.2 mm all equivalent is used, which says that if the front part is made up of plastic rather than metal, it should have a mass of plastic 0.2 mm. Alright. Fourth point says that front part is made up of aluminum, plastic, laminate or carbon fiber. Now moving towards the advantage of cassette front, which says that the cassette has got strength and stiffness, means it is strong and it is rigid. Plus second point says light in weight, means it has got very light weight so that we can handle it comfortably. And the third one is low beam absorption. Photon energy is low. Why? Because the front of the cassette is made up of low atomic number. Example, we use plastic, carbon or metal is used, but metal is used for the strength of the cassettes. Alright. So that is why the absorption of the X-ray beam is low in front side, because the atomic number of the used material is low. So moving towards the second part of the cassette, which is cassette back. The cassette back's first point says that it is either made up of metal or plastic construction lined with lead foil, means it is lined with a lead foil all round. What is this lead foil? Lead foil is the lead which is foiled all around the back of the cassette. So why we use here lead foil? We use here lead foil to prevent backscattering of radiations. What is backscattering? Backscattering is the reflection of radiation waves back to the direction from which they have came. And because of the backscattering, there is a fogging of the image, means there is a destruction of the quality of the image. So that's why we use lead foil in the cassette back, to prevent the fogging of the film, to prevent the backscattering of the radiations. And this is the important question as far as the examination point of view is concerned, that why we use lead foil in the backs of the cassette. Second point says that it should have a lead equivalent of at least 0.12 mm when operating at the 150 kVp construction potential. Means it should be made up of a lead equivalent having at least of the mass 0.12 mm when operating at 150 kVp construction potential. So in the cassette back we use material made up of high atomic number like lead. Now moving towards the cassette fitting, the fitting is made up of clips of fasteners, usually made up of stainless steel. We use clips just to hold cassette's front and back tightly together. Hinges is used for the same purpose, that it holds the cassette front and back tightly together, and it's made up of metal or plastic. A pressure pad, it's made up of plastic foam. Here you can check it out. Here's a foam pressure pad. Foam pressure pad is used to keep screen in close contact with the film once loaded into cassette. Here's a lead foil sliding shutter, which is used for the identification of patient, where we usually mention the name, age and sex of a patient. Here's a lead blocker, front intensifying screen, back intensifying screen, and hinge in the middle. Now moving towards the function of cassette, the first point says that to hold intensifying screens and protect them from damage. Second one is to exclude light from entering from cassette and fogging of the film. So it does not allow light to enter from the cassette, so that there is no fogging or distraction of the image quality. Third says to maintain a close and uniform contact between film and screen. Fourth is to exclude dust and dirt from sensitive screen. Alright. Now moving towards the features of an ideal cassette, the first point says that it should be strong and rigid. Second, it should be having a light weight for easy handling. Third, it should be easy to open and close under low light conditions. Means whenever there is a low light condition, it should be easy for us to open and close the cassette. Fourth one is no sharp edges or corners. So it should not be having any sharp edges or corners which can cause damage or harm to a person while handling the cassette. Fifth one says that cassette front must provide minimal beam alternation. It means the cassette front should provide less beam absorption. Alternation means absorption, though, so there should be a less beam alternation absorption from the front side. For that we use low atomic number material like carbon fiber, or we use plastic from the cassette front as already discussed. Sixth point says that it should be having a sliding shutter for identification system of a patient. So there is a sliding shutter where we just collect the information of the patient like name, sex or age. Seventh point says that it should be slightly larger than the X-ray beam and area to be radiographed. So cassette should be larger enough than the X-ray beam and the area to be examined. Part of the body, it should be larger than that. Next point says that the availability and range of film sizes. It means cassette should be available in different sizes according to the film sizes. Alright. Last point says that it should be sold with the same guarantee of quality. So this was all about today's topic, X-ray cassettes or radiographic cassettes. For any queries, questions or confusions, you can comment in a comment section, or you can tag me on my Instagram ID mentioned in the description of the video. Thank you for watching. Take care.